Hello, I'm Robert, and I'm doing this for the Facebook group Doomsday Debunked to help people get scared of various things. And so this is my article about 11,000 scientists sign a climate paper. And so a lot of people are very impressed by this. They think, if 11,000 scientists sign this, surely that must mean that this paper is correct. But these aren't people who've actually reviewed it. They're not. It's not like the IPCC, which is a careful, thorough review, and you have hundreds of scientists come together and they work together on the report together, and it's very structured with the co-chairs, the chair, and the people who work beneath them, the working groups, and so on, and they go through all the sites in the literature for climate change, and working it together. It's a field that's far too vast for just one person to survey by themselves. And you need these hundreds of scientists just to get a grasp of everything that's there. And they give a thorough review of the entire range of the findings in the well-researched papers. And this is nothing like that. This is just one person, just a few people doing a short paper. And if you go and look at it, it's only got hardly any cites at all. Just find that I've got the paper. I'll get to the paper, find the paper and bring it up. I should have brought it up. Where is the paper? You'll find that at the end. And these people did previous papers in 2017 and 1992. And so if you have a look at it, it's got those 1, 2, 3, 4, 5 authors, and if you look down, if you're used to the IPCC reports, there are hardly any cites. There's one there. You see, it just says IPCC 2018. It doesn't give a section number. Biggs et al. 2015, and then the figure supplemental file. That's just signatures, I think, is it? And then you have these figures, which we'll come to in a minute. They're rather incomprehensible. And then it goes on. You can see again. This is not usual for a scientific paper to have so few cites in it. IPCC 2018, this is the only one with a section number, and we'll see that that is mistaken. It's just to cite that short phrase. That's the only phrase in the entire thing that is cited to an IPCC section number, and it is wrong. And then you have more IPCC, it just cites the entire report. That's very sloppy. It doesn't say where in the report. Again, IPCC just 2018, it took about hundreds of pages there. How are you supposed to find it? And then this is the only, this one that's scaring everyone, this paragraph here. It's only got this one site, 2018, which we'll come to, and this bit, entire bit, then that entire section that's worrying, the especially worrisome bit. So, it's a very, very sparsely sized paper, and it's not, and it only gives like one site for one point of view. So let's go and see what the problems with it. So first of all, I say the language is vague and imprecise. They say uninhabitable. So if you go and look at that sentence that I was looking at, these climate change reactions could cause significant disruptions of our ecosystem, society and economics, potentially making large areas of Earth uninhabitable. What does uninhabitable mean? So try and think to yourself, what normally a scientific paper would define terms like that. They wouldn't just leave it hanging in the air. This one doesn't. So try and, for instance, there was one that I was talked about recently that defined heat waves and said they were deadly heat if there was one person in 10,000 has a risk of dying if they don't take the proper precautions. So they had the term deadly heat, and it doesn't mean the ordinary English word deadly heat. It just means this, a heat wave with this 1 in 10,000 chance. And that's how you would do it in a proper paper. It would mean something. It wouldn't just be a word like that, uninhabitable, that you're supposed to guess what it means. So have a try and see if you can guess what it means. Does it mean anything to you? And if so, what? And then I'll come to some of the possibilities and what the problems are. So, and then the only actual figure it has, the only actual section number site was that one that I mentioned. And let's see the use the deferred tax. And then use price. Yes, here we are. But the global emissions weighted average price per tonne of carbon dioxide was only around 15.50 to 25. Much higher carbon-free price is needed. And so this is a typical thing that is cited as being a huge problem and saying that we just can't do it because the carbon pricing would be too high. But if you go and look at what the IPCC themselves say, the actual exact number they gave is $7. Which is even less than 15.55. So let's go and look down at that bit now. Those are all the comments. So there we are. The New York Times made a similar mistake in their article back then when they said that heavy taxes or prices on carbon dioxide emissions, perhaps as high as $27,000 per tonne by 2100 would be required. And that got widely shared and publicised soon after the 2018 report, but that was wrong. If you go and look at it, it says at the very beginning of the section, the price of carbon assessed here is fundamentally different from the concepts of optimal carbon price in a cost-benefit analysis, or the social cost of carbon, those are three different things. And so the optimal carbon price in the cost-benefit analysis is what you would use for taxing. And the social cost of carbon includes all sorts of intangible things, effects of it. And then the price of carbon there, it's not entirely clear what they're talking about, but I think it involves things like the cost of if you don't do it, or the cost of for instance, your sea defences, then you'd have to price all that in what the carbon is costing you by emitting that carbon dioxide. It's very different from what you would use for your for taxing. And so they go on to give these huge numbers for the actual price. And they say that by 2100, with let's look at the below 1.5 degrees C, it goes up to $14,300 up to $14,300 in 2050, and up to $19,300 in 2070, and up to $30,100 in 2100. That means that for every ton of carbon dioxide you're emitting, then if you want to stay within 1.5 C, if that's your goal, then you're losing. That's how much price that you. That's the price that you're paying for if you don't do that. So compared with if you do manage to stay within 1.5 C, but it would obviously be ridiculous to have a tax of $30,000, and they don't say that, and they say, and if you go and look at the taxes, then it says a mix of stringent energy efficient policies, and they say like minimum performance taxes, standards, building codes, combined with that carbon tax rising from $10 in 2020 to $27 in 2040, is more effective than a carbon tax alone, and which would be from 20 to 53. So even the carbon tax alone would be $20 rising to 53 to generate a 1.5 C pathway for the US electricity sector. So they're not saying you use thousands of dollars. They're saying that that if you have minimum performance standards and building codes and efficiency policies, then you can have $10 going up to 27. But they're saying that if you go a little bit further, and you also have a ban on new coal-based power plants, and dedicated policies addressing renewable electricity generation capacity and electric vehicles. So you're doing policies to encourage a transition to renewables and to encourage electric vehicles. and you mix that with the Montes carbon price of $7 per tonne, then that actually reduces, you actually get less losses through efficiency than if you have an optimal carbon pricing without all those other things. And then they go on saying that from a bottom-up approach, that stringent minimum performance standards can effectively complement and that in ways that are impossible even with the carbon price of $100 or higher. So they're basically saying that a carbon tax on its own, 100 dollars per tonne, is not going to be as effective as for getting manufacturers to be efficient in produce efficient refrigerators and so on, setting stringent minimum performance standards. And so this whole thing, and their recommend is $7. These are 2010 dollars, of course. So you'd have to adjust a bit for 2018 dollars. And so anyone who signed the letter, either they don't care about there being inaccuracy in it, or they didn't check that site. There's no way of knowing which it is. So these 11,000 people, they're not like the IPCC. Such a thing would never get into an IPCC report. So, I actually read out from the IPCC report. It's very precise, detailed, careful work, and it's not this sloppy stuff that we've got here. And they don't even say a much higher. They have these words, vague words all the way through. A much higher carbon price. What does a much higher mean to a scientist? They don't explain. If they're given a figure, then we could have gone to that page and found out which figure they were talking about. But it's so vague and wishy-washy and woolly that you can't actually tell what. And then that's the only section number cite. Often they're just citing an entire report of hundreds of pages or dozens of pages or hundreds of pages. There's no way of knowing what they're talking about. So then another thing about it is that they claim that global warming threatens the fate of humanity. So, as I said, that's the fate of humanity. Threat is more severe. The climate crisis arrived and accelerating faster than most scientists expected. Again, what does most scientists expected mean? Which scientists? What did they expect? What does accelerating faster mean? How much faster is accelerating faster? It's very, very imprecise. And then they say it's more severe than anticipated. What is more severe? How much more severe? What was anticipated? And then they say threatening natural ecosystems and the fate of humanity. I mean, the fate of humanity, what else can that mean but human extinction? The actual fate of humanity. I mean, so, and they cite that to IPCC 2019, that's the report on the land and on something, climate change in the land. And that has nothing about it threatening the fate of humanity. I mean, it's not in summary for policymakers, I can say that for sure, because I read that all the way through, and I read a fair bit of the report. But I mean, this wouldn't be hidden away in a little detail. So, as I said, how does this world threaten the fate of humanity? This is a recent 2018. I think it might be in 2019 report. Anyway, a very recent study of what would happen to Greenland. And according to low emissions, see, we just have the ice all the way through. With business as usual, then we can get all the ice melting by the year 3000. But this is the year 2100. Business as usual is when you have just continuing emissions, just as we have today, continuing without any reduction at all the way through to, in this case, to get all the way to there, then you continue those emissions until all the fossil fuels are used up to 2200. That is not a scenario. We can't even go on that. I mean, the renewables are too competitive for with fossil fuels now for that even to be a plausible scenario anymore. So, and that's my little. I've done these as memes. Hopefully, it shows up in search results or in Facebook, so people might just think a little bit about, is this really right? So I say you could read it in 10 minutes. It doesn't have any complex arguments and very few cites. So most of them have probably read it, and perhaps some of the cites, but there's no check of it. They're just signatories. It's like someone signing a petition. If you go and sign a petition at change.org, there's no check that you actually read that petition even all the way through to the end, and there's certainly no check that you've gone and checked and done a search on the internet to see if everything they said in the petition is correct. And you often get these petitions there, and they say things that aren't true. And nobody checks them, then you get thousands of signatures. And this is basically what's happening here. So they then talk about the tipping point. So, I mean, these are scientists, they're a bit more thoughtful maybe than others. I'm sure they wouldn't, hopefully, very few of them would actually do the same, do this sort of thing in their own research. But they're just assuming that this is right. And they probably, as I say here, that I have one of the people I help is an academic who's a professor in a related science area, and she makes this comment, which may well be a very similar situation to what those. Let's see if I can find it. Yeah, she said when I did this share your doomsday fear story, and her fear is climate change. And she says, I like to think of myself as a smart person. I am a tenured professor, a scientist, so I should be able to judge the credibility of these stories. However, oftentimes scientists would not speak up against these stories or even tweet about them in a way that implied endorsement. This is not my area of expertise, and if scientists in this field agree that these stories are accurate, if high-quality newspapers write these things, then I start believing that they must be true. So it's not too surprising if scientists who are not actually these signatures, it's not 11,000 climate scientists. There were 190 of them in total that claimed to be climate scientists, said that they were climate scientists. They had climate or climatology in their name, in their what they said they did. Many others, things like forestry, ecosystems, geology, probably scientists for the USGS and things like that, and they're not people who are researching into this. And so now, so I'm going to go in a little bit more detail on some of these points. But first of all, why does it matter? So I certainly agree that there's certainly, I think, just about anyone who's got an interest in climate change, apart from people who just deny they're possible at all, would agree that this is important and that we need to increase the pledges. Indeed, the Paris Agreement is set up so that they do increase the pledges every 5 years. The next time is in 2020, and hopefully a lot of countries will increase their pledges. That was all it said. If it just said, we need to increase our pledges, it's very important to do this, and they gave the evidence just as there is in the IPCC reports, it would be totally uncontroversial and very understandable, and just about everyone would sign it who's got any interest in climate. It wouldn't be 11,000, it would be hundreds of thousands probably. I mean, well, just as many scientists as there are who are interested in climate change, which would be a vast number. And but the controversial thing are these things about it saying it's uninhabitable and about having tipping points and untold suffering that they talked about. That's another of these strange words. What does untold suffering mean? You won't get that in an IPCC report. And that is the controversial thing, and it ties in with this thing of the Extinction Rebellion, who are going around telling everyone that we've faced human extinction, that we're heading for an uninhabitable world. And there's nothing here to explain that that's not what the IPCC are saying. The IPCC don't say that at all. And they don't say there's a risk of billions of people dying. The IPCC, for instance, in the 2018 report, they have an example of a worst case scenario. And their worst case scenario, through to 2100, you can still feed everyone. In 2100, you have enough food in the world for everyone. But you have diminished food security, more risk of famine, but there's enough food in the entire world for everyone. You're not talking about a future where you can't feed everyone, but there might be political and economic and other difficulties to make it difficult to have food security over the entire world. That is the worst case, going backwards to the past. Like if you remember the famines a few years, like when I was rather younger, and nowadays we've more or less ended and they're really big famines. Like, but we have this that hasn't been a really major famine like we used to have, like when I was at university for a long time. And for the last decade we've had very good food security. I know lots of people are hungry, lots of people are malnourished. We're nowhere near where we headed for. We've still got these sustainable goals. But what they're saying is that if we don't act on climate change, we not only won't achieve our sustainable development goals of zero hunger for everyone and fresh water and clean water for everyone, we will actually go backwards on it and go back to where we were a few decades ago by 2100. And that's awful if that happens. As well as all the problems with more climate change disasters as well, like hurricanes and the flooding, and having to losing land to flooding or very expensive sea defences for poor countries. So that's the problem. That's why we've got to do such a lot. Why it's so important to do something. But we're not facing a world where we can't feed everyone. And so they also say that we need to stop population growth urgently. That's not what the IPCC say. That's nobody's saying that. That just comes out from thin air. They don't really. I think that's one of their uncited. No, that's cited to a very dubious, They cite that. Right, let's go down to that part of the page. Right, they cite that to a single paper that itself acknowledges is controversial. And the site does not say, and it doesn't even say what the site says. They say the world must be stabilised and ideally gradually reduced. The paper that they cite is called Global Warming Policy, Is Population Left Out in the Cold? With a question mark. And it opens with a question, would slowing human population growth lessen future impacts of anthropogenic climate change? With a question again. And then goes on to argue that the answer seems an obvious yes, because of the 4 billion extra people on the planet, and because many of the least developed countries have family planning programs and see population growth as an important component of vulnerability to climate impacts. Now this much is true, that we will have, but if first notice all the way through this paper, they're talking about least developed countries. This paper they cite is not saying that we have too many people in the world as a whole. It is saying that in the least developed countries with rapidly growing populations, then they have a big problem with growing populations, which is true. And Bangladesh is an example. If I search my page again for Bangladesh, they give that, right, yes, there we are, we've got Bangladesh. Yes, there we are. So if we open that link up, then Bangladesh do have a very major family planning initiative. Here it is. In Bangladesh, family planning remains one of the top priorities in the 4th Health Sector Programme 2000 as a path towards achieving the Sustainable Development Goals. It's prioritised using the National Action Plan, implementing National Action Plan, and that includes unmet need amongst adolescents. It includes they have a commitment to end child marriage, which is still a thing in Bangladesh. They also have, it's important to increase trained service providers, including deploying midwives to all sub-district hospitals and improving supervision and clinical teams and so on. That is obviously very important for Bangladesh. And it's very important for the healthcare. But notice it's not just family planning, it's also making sure that the mothers are looked after carefully, that they can have their birth safely, that children are safe, and are born safely. They also, an important component of all this is that the children are healthy and they reduce child mortality of young children, and they grow up healthy to adults. And this is the main. It's not just handing out family planning advice and making sure that everyone can stop having children if they want to. It's making sure that they're in a context where they're supported to do that. And that support is absolutely vital. Without it, they're not going to want to, because the problem is that the biggest problem in population growth, and as I show there, we have actually reached almost peak child. There's the same number of children now as there were a decade ago. But population is growing because we are living longer and longer, because we're more prosperous and more healthy. And to say that we need to reduce the population very quickly because of that, it's very strange. And so anyway, back to, now here you can see, this is how it is done. In Asia, it's going to peak. And it's still growing in North America, it's in Latin America still growing, but it's hard to tell when there was peak in that. I've got another figure that shows it better, but it's not on this page. But Africa, you can see, is everywhere else is levelling off, all peaking before 2100, but Africa is continuing to increase all the way through. And so the main reason, if it weren't for Africa, then it would reach a peak around 2050 and then decrease, or before. So Africa is the key there. But it doesn't mean that we go out and tell everyone in Africa you could have fewer children. The reason they have more children there is because Africa needs increased food security, education for women, higher education, women in work, reduced child mortality. Those are some of the key points. And if we do that, then the African population will mirror the Asian one and peak around there. And we end up with a much, much lower population at the end there. If you imagine if that peaks around there, rather than peaking there, that's what we need to do. And there are signs already that they're having lower birth rate. And higher education is very important. Actually, surprisingly, tertiary education, universities and colleges is very important too. This is a complete population scenario that involves education and everything, a complex model. And in this one, with a high level of university and college education in Africa, then it peaks around 2050. If you don't have much education, then it goes straight up like that. If you have a mix, then it peaks, but it more or less levels off and doesn't peak so well. So it's interesting to know how much an impact tertiary education has. And education of women is especially important. They found that more education for women can knock 1 billion off the projection for 2050. Not the projection for 2100, but from the projection for 2050. This can be 1 billion less if you have education for women up to tertiary level in Africa, sub-Saharan Africa. So that should be our priority. And educated women have less children, they're better able to support themselves and their children. There's more prosperity, more health. And this is what we need. We don't need to just go out to Africa and give them lots and lots of family planning and contraceptives and I hope that'll sort out their birth problem. And we don't need to reduce the population in anywhere else in the world. And this paper, the paper they cite doesn't mention any of what I just said. And that is the only site that the paper these 11,000 people have signed has as a site. So they cite a paper that doesn't mention any of this. And they of course don't mention any of this themselves. And another thing, if you're worried about how can the world have 4 billion extra people, it is interesting to notice that sub-Saharan Africa has the greatest potential for potential growth. Its agriculture is way down there. Many of their countries down there, compared with China, it's about the 10th of the productivity. The reason is that sub-Saharan Africa, we had the Green Revolution, which many of you probably, well, you weren't even born, and I was very young at the time, I didn't know about it, but it was the 50s and 60s, when we faced the possibility of billions of people dying of just not having enough food, because the population was growing and food supplies weren't growing enough to keep up. And there was a big push amongst scientists. It wasn't just something that happened naturally, it was a targeted, combined effort by many, many scientists worldwide to increase the productivity of crops. At that time, not through genetic manipulation, it was through breeding. And at the same time, looking at crop methods, at fertilizers, at irrigation methods, at all the methods for growing the crops. And as a result, they produced crops that had much, much higher yields than they had before the 1950s and 60s. And that is why China's way up there. It's been way down there like sub-Saharan Africa if it was if they hadn't had the Green Revolution, and we'd have had billions and billions and billions of people dying if it wasn't for that Green Revolution. That Green Revolution hasn't happened in Africa, in sub-Saharan Africa. It was targeted for things like rice that they grow in China. They don't grow a lot of rice in Africa. And and for the conditions for places like China and Asia, and Europe, of course, and the Americas. But they haven't done a targeted green revolution for the crops like cassava and the conditions of sub-Saharan Africa. So we need new varieties to grow there. They need, I mean, they'll be doing it, it's not like we're doing it for them, as it were. But they need, that's a collaboration and transfer of knowledge and technology, of course. And they need to develop better varieties, better methods of agriculture, and then they'll be able to push these yields right up there. And that'll feed an awful lot of the increase in people in our world, because most of the increase is happening in sub-Saharan Africa. That's what we need to do for the food. And then, as well as that, they have they have only 51 people per square kilometre in sub-Saharan Africa, compared with 460 in India. That's nearly 10 times as much people per square kilometre in India than there is in sub-Saharan Africa. That also helps you to see what a huge potential they have there. A fourfold increase in population in sub-Saharan Africa is not a disaster for the world. We can do that if it does happen. But their 1 billion increasing to 4 billion doesn't necessarily have to happen. It can just be a small increase if Africa is able to achieve faster progress towards prosperity for everyone, higher education, especially for women, equal opportunities, and better healthcare and reduced child mortality. It's kind of paradoxical, but having fewer children actually is better for reducing population growth. Not having better success for children. If all your children, like where I live in the UK, I mean, it's very, very rare for a child to die before they're say 20. Would usually be something like an accident or some very rare disease or some kind of major problem. But if you're in sub-Saharan Africa, that's very common. Just through malnutrition, diarrhea, diseases, and lack of healthcare, and that has to be fixed, because while their children are dying, and they need to have more children in order to make sure that some of them survive to adulthood. Just like in Victorian times in the UK, people used to have huge families, but the population didn't grow rapidly because many of the children died. That's the sad fact about what Victorian England was like, or Victorian Britain. And you read the stories about the huge families they had, but they didn't have a rapidly growing population, which had been growing multiple times, doubling every every few generations, every generation more than that, 4 or 5 times. I don't know what their birth rate was, but they didn't grow to maturity, and so that was why. Well, sub-Saharan Africa is in that situation, and so just like in Victorian England, naturally enough, they have lots of children. So that is one of the keys for helping people for reducing population growth in sub-Saharan Africa, is that they need to have and then they're in a transition, you see, with lots of children, but becoming a bit more prosperous, and so more of the children grow to adulthood than the parents expected from their generation, and so you get a very rapidly increasing population. So it's a little bit education as well. They do need there's education programs there saying, actually, your generation doesn't need as many children as the previous one, as well as, but it has to be combined. You do have to have the reduced mortality and improved health care, and then the education and everything. So they're completely off the ball with the population thing. It's just nuts. They can't have done much research into that. And now you have the tipping points. So they talk about how especially worrisome are potential irreversible climate tipping points and nature's reinforcing feedbacks could lead to a hot house Earth. So and then they talk about potential lead. Oh yes, the word uninhabitable. I said you try defining uninhabitable. So what do they mean? Potentially making large areas of Earth uninhabitable. So before I go and talk about the problem with the feedbacks, so what does it mean, uninhabitable? Because humans, you can survive in the desert, in Sahara Desert, with much hot, very hot conditions. You can survive in Death Valley if you take the right precautions, and the Kalahari Desert. And the Bushmen, of course, used to live there, with very primitive equipment, and digging for roots and things. What does uninhabitable mean? And so, does it mean you can't work in paddy fields for a few days during the very hottest heat waves? That happens for the hottest part of China and some other areas at around 4 degrees C. That doesn't mean that you can, and in fact that's only for 6 hours in the heat paddy fields. You could go out for 3 hours, then go back and cool off in your house, and then go out again. And you'd still be able to do some work, even in the very hottest days. So, and that's at 4 degrees C, and we are headed for 2.9 degrees C. So we're not headed for that. Or does it mean you need air conditioning to survive on the hottest day and the hottest heat wave every decade or so? This means even indoors, even in shaded conditions, that you just is unsurvivable for the human body. That happens to around 7 degrees C, according to one paper, and that's in the Persian Gulf. So we're even with business as usual, that's way up at the top end of the projections. It's beyond it really. Or does it mean there's a 1 in 10,000 chance of dying if you don't take the proper precautions? So this was the global risk of deadly heat, which is a story that hit the news that you may have seen, and a lot of people got scared that meant that everyone's going to die. They didn't realise that it already affects 30% of the entire world population a year, and we don't have 30% of the population dying every year. It's not about that at all. It's about the elderly, the young, foolish people, who sort of don't drink any water and race up and down, and haven't drunk enough water and then die, or spending out too much time out of doors without much shade. And we have actually had people die in 2003. It's not a huge amount compared with the number of people who die anyway, because obviously always people are dying, and that's just a matter of life. But there's a very noticeable increase in the number of people who died in nursing homes, young children, and so on. And so since then we've had these this new advice which is whenever we have a heat wave, then we get public education to make sure that we know what to do in a heat wave. So if you go and read the news, it'll say, if you're in a heat wave, do this. And so that's made a big difference. And they also have this colour coding thing that say how bad a heat wave it is and things. We very rarely get heat waves in the UK, but we do. But now far fewer people die than they used to. And that is what that was about. And of those 1 in 10,000, none of them needed to die. So if you mean that, then that is true. And that is true even now for 30% of the population, and increases to 75% by the end of the century with business as usual, which we're not on and we can't get onto really. And that doesn't mean large areas of the world uninhabitable, and that's the only actual thing in the IPCC for our current path that we're on now that they could be referring to. And that's obviously not uninhabitable. So then if you look at their site, Trajectories of the Earth System in the Anthropocene, then this is not actually about what happens this century. It got very badly reported in the news, with people suggesting that it's saying the world's going to become uninhabitable this century. But it wasn't. It was about very long time scales over. It's about the equilibrium. Like, for instance, the permafrost, which is gradually thawing. I've got a diagram down here. Again, I'm going back and forth, because doing it in a different way from here. I go down to. I'll search for the. I didn't want to delay it too much. I wanted the reader to get quickly to the main points. So some of the more details I put later on, rather than interleaving them. So this shows the melting of the permafrost. This is one recent 2018 paper. This is roughly the path we're on now. That is roughly business as usual, which is if we kept the CO2 emissions all the way through to 2100, then even through to 2200. And if you look at the time scale, this goes through to 2300. And if you look at what happens, if you look at the vegetation, that's the key to the tundra. And you see, nobody really knows what's going to happen. This supposes that the vegetation is actually reduced, the carbon from vegetation as the permafrost melts. But this is obviously one that is saying it's going to reduce and then increase. It's going to say increase a bit, and this is another possibility it could increase a lot. And you get the whole area covered in woods and stuff. And this is very hard to model. And this is what happens to the soil. So the soil, if the permafrost, you need to understand that the permafrost in the Arctic, it's got frozen ice from thousands and thousands of years ago. I'd have to look up the numbers, so I'm just going to say thousands and thousands because I can't remember the number. But a long time ago, these animals got frozen in the permafrost, little creatures and their dead bodies and the grass and the roots and so on. And if they go and dig a tunnel in the permafrost, you'll see all this ancient vegetation lining the walls of the tunnel. And the problem when it warms up is that this starts to decay. So all the carbon dioxide released, it's not like the methane clathrates in the sea. It's not it's not frozen methane or anything like that. It is dead creatures and dead animals, dead plants and things that are going to decompose. And what happens when it decomposes, and that's the big question. So, for instance, if it's covered in water to some, in wet soil to some depth, then very little, and then it's likely to be anoxic at the bottom. It'll produce methane, but very little of the methane will make it all the way to the top, and there'll be other microbes that eat it on the way up, and very little methane gets into the atmosphere. It can produce methane, it can produce carbon dioxide. Both of those can be sequestered, both of those can be released. If you have peat, then the peat growing takes in carbon from the atmosphere. If you have plants, then the trees, as the trees grow, then just the body of the trees, they take in emitting in material, that's the vegetation down here. So that would be trees and bushes and grass, and this would be the soil, which the soil also sequesters carbon. And it's just extremely difficult to model what are the microbes going to do when it warms up, and what are the trees going to do, it's manageable as well. I mean, for instance, if you want a peat bog, you could just block a stream or river, and then you'd have more of a peat bog above. You can also manage it by, for instance, deciding whether to put out the Arctic fires or let them burn. So there are some quite simple ways we can manage this, which can make a difference too. So it'll depend on all that, and many things. And so there's no way of knowing. So if you now look at this, the ecosystem, and this is what everyone assumes, this blue line, that the ecosystem could lose masses of carbon. The permafrost in the soil is just completely lost, and very little comes to replace it. Even not very much vegetation, indeed almost no vegetation. But this is another possibility, that it just even on business as usual, it could be that the ecosystem continues to sequester carbon all the way through. That is still a possibility, and they haven't ruled that out. And you get occasional studies, but they have these huge error bars. There was a recent one that said it's almost definitely going to lose carbon, but it had such a big error bar that it still remained possible that it's going to gain carbon. And the problem they explained there in the recent report on climate change in the land, that the problem here isn't kind of methodological issues. It isn't understanding the physics or the science of it. It's actual problems in actually knowing what's going to happen, and difficulty of modelling that, because you don't know. We don't have enough understanding yet of what's going to happen in the area. If we knew what's going to happen, they could model it. So it's rather different from some of the other situations. So the permafrost is a big unknown. So this anyway. This Anthropocene thing, they're not looking at this up to 2100. They're looking not even 2300. They're looking way down here. What would happen thousands of years into the future? The question they asked in that paper was, what is the? Let's see if I can find my. Let's see, I can maybe bring up. Let's find it at different points in. Actually, I can bring up the paper, or I can maybe bring up the paper perhaps, and I can bring up my section talking about it. But I think, yeah, I might not scare it to help. See which one comes up first. Yes, right. So they've got their graph here somewhere. So, right, there's this graph. So they say we're here, and then we've got the two dips. That's the stabilized Earth. So they say that with the right decisions, we can head to a slight increase to a stabilized Earth. And they don't, and this is entirely a concept paper. They don't actually give any figures. You see that they're just concept diagrams. There's no numbers here. This axis is just a stability, time. That's the time. That's stability. But they don't. There's no ability. There's no number for the amount of stability. And cold and hot. They don't say how hot is or how cold is. It's a very vague paper. And it's not just it's not labelled. It never says how hot is or how cold is. And then they say that if we warm up enough, then we could get into stabilised Earth. They don't really give reasoning for that either. And they're just saying that they think this is what it's like. And they think there's another dip where it gets hot, and there's another dip where it gets cold. And we've already missed the next ice age. I mean, that's already, everyone agrees on that. They're saying that if we increase, then we can go like that. And if not, we go like that. It's just very conceptual. It's not really, I mean, it doesn't really explain what this axis is either. So that's this paper. Then if you go down again, then they look at these various things. So these various things they look at, the various tipping points. But they are not even quite sure why they've got the coral reefs in there, because they are not sure what effect that has on climate. Permafrost, Arctic winter, Amazon rainforest with a very small effect. Greenland, Iceland, Eastern Iceland. But they're saying that we keep going until all these things reach their equilibrium, whatever it is. And then they say if you do that, and if I can come down, then we find this other graph down. Where's their graph? I've missed it. Maybe their central graph. Oh, there we are. There we are. Right. So what they're saying is that it's another way of looking at the same thing. It's saying is that we could go into a stabilized Earth, which goes round and round like that in their view, or we would go into an ice age cycle, which goes like that. So that's with temperature versus sea level. So the hot Earth would have a high sea level, and temperature goes up, and the sea level increases, and at a certain point, and they think the temperature is going to go down and sea level decrease. And then they say a similar thing in the Ice Age. Again, that's what they call it, a schematic illustration of possible future pathways. And it's a rather vague paper, really, but it's interesting concept study. But they explain at the end, they're not. As you can see, this is no substitute for the IPCC. There are no dates here. This paper is not going to tell you what's going to happen in 2100. And yet that's what these people are using to cite, and they're saying we should use this to guide policy. We shouldn't. This is a rubbish site to use for what they're using it for. I'm not saying it's a rubbish paper. It's a decent paper, but it was very controversial at the time as well. So if you go and look here, the team stress that they're pointing out the potential danger that needs study, not that they've shown conclusively that this will happen. We're discussing a possibility, not a probability, and ask the scientific community to put our scenario to the test, says Sheldon, however you say that. And so they're saying they're talking about this cascade of tipping points. They're saying to other scientists, please look at this with your detailed models, which of course they model these things anyway already. So they're sort of saying, look a little bit careful about how things cascade. And that was an interesting point to bring up, which scientists have been bearing in mind since then, perhaps a bit more as a result of this study. So it was a useful thing to look and see how one tipping point affects another one. But tipping point, remember, doesn't mean the climate suddenly changes. With the permafrost, it's over centuries that it has an effect. And the actual effect of the permafrost melting is a tiny fraction of a degree over through to 2100, even with the worst case scenario. It's significant compared with human emissions if we want to target 1.5 degrees C. But if we target 1.5 degrees C, then reducing human methane emissions can offset the entirety of the permafrost emissions. So it's not such, and more than offset, just feasible reductions of methane, not reducing them to nothing, but feasible reductions can more than offset the permafrost temperature effect, except for the most extreme of the permafrost temperature effects, which we'd probably only get, which we're not likely to get on the 1.5C path, or the 2C, or even the 3C path. So it's we can't actually do anything about the permafrost it's already thawing, but it's a very slow process, and we don't need to worry about it because it is so slow, and it's not even going to push us up. It's only going to push us by a fraction of a degree, even through to 2200 or 2300. It's still only a fraction of a degree, and we can do as much carbon offsetting as we like over that time period. So anyway, and as it comments here, New Scientist comments, indeed other climate scientists that New Scientist spoke to, who did not wish to be named, expressed skepticism at his findings, although others thought it was reasonable. Because, that's not surprising it's skeptical, because it's just so vague and wishy-washy. It's interesting, it's schematic, it's a good thought thing, but it's not really findings, it's more kind of suggestions and findings, I think. I think calling these findings is to give it too much dignity. It's not findings. It's very interesting concept study and suggestions. And that's all this paper is. It's not findings, really. So, and if you look at the IPCC tipping points, then they didn't find any tipping points in the big difference between 1.5 and 2, and even at 3. There's no, even in the new one, which is looking at a much wider range, they don't find any short-term tipping points. But they do find long-term ones. They find tipping points of the ecosystem, for instance, for the coral reefs. And there is where it's possible that as we reach 2 degrees C, then there's a rapid transition to very little by way of corals. Not kind of instant, but quite fast. So that's the closest they have to a tipping point. It's not really for the Amazon. That is now more robust than it was used to be thought. As a precautionary measure, it's good to take precautions, but it's a slow change to savanna at about maybe 3 degrees C or so. Then there is the western Amazon never gets lost, and there's a very slow transition in the eastern savanna. If you do too much deforestation of the Amazon rainforest, then, and if you keep doing that deforestation, the continuing deforestation combined with the effect on climate of removing those trees, then you get a feedback effect there in the Amazon. But it's a slow one. And actually, I don't want to get too much involved in that. I've got another article about that, and how it's actually quite promising that there's the at the same time that they're cutting down the forest in the Amazon, they are improving the efficiency of the agriculture. And at a certain point, maybe around 2025, according to one paper that I read, then it'll tip over, and they won't need to deforest, even with increasing requirements from the agriculture. But I don't want to get into that here. So anyway, so Greenland ice is a tipping point between 0.8 and 3.2 degrees C, with a median of 1.6 degrees C. And the tipping point is that it's warming so much that the ice is eventually going to get thin, and when the ice gets thin, it's difficult for it to thicken again. With an ice sheet like that, it needs to be much colder to thicken than it needs to thin. So that makes a kind of tipping point. Tipping point is one that you can go one way, and you can't. It's a bifurcation behaviour where it goes one way and then it can't come back the way it came. You need to get it much colder. So it would sort of go. If I go like that, it goes up like do like that. It goes up like that. Then to come down, it's got to go like that, because it can't go back the way it came. So Greenland is a bit of a thing like that, and at 0.8 degrees C, but it's also a tipping point in that it means that it's once it's gone beyond that point, which we could have reached already, but we probably won't reach for a little while, then that means that eventually it's all going to melt. But they're talking about between 80% loss after 10,000 years and complete loss after 2,000 years. Now, they came up with slightly different figures from the one that I got at the beginning of the article, where it was 3,000 years. That's a more recent paper. So these, whether 2,000 or 3,000, I think they can be a little bit unsure about the complete losses, and it also depends on what the error range is, what the significant range they give. But you're talking about the complete loss may be possible 2,000 to 3,000 years in the future. But that's depending on future climate, you see. So that's with the business as usual, and then with what we're on now, it's 80% lost after 10,000 years, especially. So that's the that's that. So what else have I got? Oh yes, and there's several other. Well, I could go through that in detail, but these are some of the things which they list as, and they call it now large-scale singular events, which risk of reaching critical tipping points can result in big associated major shifts in the climate system, but this doesn't necessarily mean a global effect. So the Western Antarctic ice sheet in Greenland, that is a large-scale single event, but the I should there's the slowdown. I better not talk too much about that because I've got to read up some more about that. But there's there is also uncertainty there about how quickly the West Antarctic and the Greenland ice sheet is going to melt. But you're not talking about suddenly losing vast amounts of it. And there's a variation in the projections through to 2100. It's a sort of meter scale. But I better keep to what I've got in this article, because otherwise I'll be going around and hunting for the figures in my other things I've written. And so you've got the number of El Ninos expected to double, and the Southern Ocean might have the amount of sink that you get, because the Southern Ocean is constantly removing a significant fraction of the carbon dioxide that we release into the atmosphere, and that might be reduced, and that's an important thing to find out. But we don't risk the clathrate gun hypothesis. That's been effectively disproved, and they just don't even figure it into the recent reports. So these tipping points, they're no longer, there are these tipping points, but they're large scale, like the long period, like the permafrost, or like the melting of the Greenland and Antarctica, unfold over centuries or thousands of years, or else they're smaller things. They're not these sort of big events, like the coral reefs tipping point, where it's not the whole world affected, but the coral reefs, and like there's a kind of amplification in the Arctic, the Arctic albedo and all that. That's not a global thing, because the world as a whole is getting brighter as it warms, not more reflective, not less so. We're getting less reflective in the Arctic, and there's amplifications going on in the Arctic, which is part of the reason why the heat is increasing in the Arctic. But it's also partly because in a warmer world, then the heat goes from the tropics to the poles more. But it does so in the Arctic, but not in the Antarctic, for various reasons. So the Antarctic is not warming particularly fast, but the Arctic is, mainly because that big thick ice sheet on the in the Antarctic covering the entire pole. So I know what else. Shall I go through and see if there's anything else that I haven't covered yet? So I hope you can begin to understand why I'm saying that this paper, we've gone through the population, we've gone through the agriculture. Oh yes, they're figures. Let's look at their baffling figures. So they just don't explain it. I looked at the thing. So if you go to where is it? There, you go to their figures. You expect to get some explanation of what the figure's about. Click on the figure. Where does it say? Open a new tab. There you get this figure, which, what's the world GDP got to do with it? It doesn't really explain. It just says what the figures are, and then it says it's explained in the supplemental far less too, and all that does is say where they got these figures from. It doesn't explain what they mean. That's a very, very weird thing about this paper, and all it says is. So look, this is what they say. Despite 40 years of global climate negotiations, with few exceptions, we have generally conducted business as usual and have largely failed to address this predicament. And this is the figure 1. It shows increasing population, reduced total fertility rate, world GDP increasing. What's world GDP got to do with the price of cheese, as we say in the UK? Because you do get world, as I explained, in case the people didn't know, that, for instance, California has greatly reducing, is rapidly reducing greenhouse gas emissions while increasing its GDP, and during that time it moved from being the 6th to the 5th world economy, if it was counted as a separate economy, while transitioning to renewables. So it obviously doesn't hurt your economy. And it was beating the UK, which is also performing very strongly as a result of our transition to renewables, and we moved from the 5th to the 6th, so the two of us leapfrogged, and nobody else overtook us as a result of doing this transition to renewables. California is doing it perhaps a bit more vigorously. If anything, it suggests that transitioning to renewables is good for your GDP. So, and all they say about the supplementary data is, although the data used are from sources believed to be reliable, no formal accuracy assessment for these data sets has been made by us, and users should proceed with caution. That's all they say about these baffling figures. And you get some of the papers and journalists sort of riffing on what they mean, but the paper doesn't explain. That's all it says. There's nothing there to explain. How is this? How does this mean that we have failed to address the predicament? Because in actuality we haven't. We've had the Paris Agreement since 2015, and we've done a lot since 2015, which is in that figure, the last little bit. And okay, the tree cover loss is still increasing. They don't explain there's also been a huge increase in reforestation. This is reforestation in Ethiopia, which planted 353 million trees in 12 hours in July 2019. And there's a lot more good news like that going on around the world. China is doing massive amount of reforestation. It's increasing its percentage by several percentage points, which is quite a lot for a nation as large as China. So this is a very one-sided thing to just show the deforestation, the global tree cover loss, and not explain about all that. And this is flipping over because the deforestation we're eventually going to stop and the reforestation is going to continue. And if you look at it by region, then most of the deforestation, I'm not sure if I put that there, I put it in here, I was going to have a graph about it. I think I forgot to put it in, I might add it in. Yes, so most of the deforestation is happening in I think Africa, South America. Europe has been having increasing amounts of forest for decades, and North America, and Asia as well. China, it's got increasing forest. You're not losing forests from China. Say it's increasing its cover by percentage points. So the main issue with deforestation is we need to do something about deforestation in South America particularly, and in Africa. And so this again, that's completely hidden by that figure. And a lot is being done behind the scenes, but it takes the various, like this Pakistan's, it had a 1 billion tree program, and all of those 1 billion trees were planted. It's now on to its 10 billion tree program in Pakistan, and there's a 1 trillion tree program in South America. So we've got vast amount being done on reforestation. And it's going to take a while for some of those programs to get underway and to really start showing results. And on the pledges, then most of the countries of the 7, I've got a bit about that as well at the bottom there. What are we doing so far? So the top 7 emitters, then US of course has left, but is still reducing emissions. Philadelphia, for instance, which Trump went on about in his talk, they have a very strong city carbon neutral aim, and they're reducing emissions from their city, and they produce, I think, they get 25% of their city's electricity from renewables already. A climate action plan that they're following, and California, as I said. So the United States, although as a whole it's leaving, there are many components of the United States which are well on course with the 1.5C goal. California is 1.5C compatible, and Canada and Australia, they're doing rather less. but maybe Canada will do better with the new government, with being a minority government and other, or even though it's functioning as a minority and it's not doing a coalition. And then Russia, it's not doing very much. Its pledge is just to not increase by very much. It's about the weakest pledge there is out there. But it is actually well within its pledge. It's got actually programs, it's got policies that are going to decrease emissions. So Russia is a little bit unusual. It doesn't want to pledge very much at all. It's almost like the US, but it hasn't actually withdrawn from it. It's just got very, very, very weak pledges. All its pledges that it won't increase its emissions very much. But in actuality, it's decreasing emissions. So Russia is actually exceeding its pledge, even though it's a very, very weak pledge. And then China, the EU and India, they're all increasing their commitments. So we're actually doing pretty well. So now what else can... but I mean, not to pat our backs on it. We're still only headed for 2.9 degrees C, but we were headed for... we're headed pretty much for business as usual by the time at the beginning of the Paris Agreement in 2015. So we've knocked about a degree off that, or more than a degree, to get to 2.9 degrees C already in 5 years. And we've got to knock another a bit less than a degree and a half of that. But we've got another 10 years to do it to get well on track for the easiest way to do it. Not to knock it all off, but by 2030 we've got to try to get to 45% reduction in emissions. If we can do that, then it'd be relatively easy to get from there to zero emissions by 2050. If we can't manage that quite, then it gets harder, though not impossible. And then if we're quite a bit up and not far off present-day emissions by 2050, then it's likely that we start to have an overshoot. And then we have to find ways of getting carbon dioxide from the atmosphere and the various methods by, for instance, burning biofuel and capturing the carbon dioxide. So yes, we're doing fine. We're doing pretty well. I mean, if you'd asked me back in 2015 and told me what was going to happen by now, I would have thought it incredible. I wouldn't have believed it before the Paris Agreement. But most people, they've just started worrying about climate change in the last year or something. And they just haven't been giving it much mind. And so for them, it seems awful because we haven't got all the way straight away. But look at what's happened in the last 5 years. So, is there anything else I need to do? Oh, yeah, so I was saying we do need our young children. Just don't listen to these people who say that you should stop having children. It's absolutely not true at all. Our children are part of the transformative change. I mean, look at all these people out school striking and so on, children out school striking. And then they're making new inventions, they're working to the future, and then you don't need to. There's this one that was another population. I've got it somewhere on the page. There was one of these population papers saying you've got to stop having children, and they did this thing of counting the carbon dioxide emissions of your children and counting them as being the emissions for the parents, with double keeping. But that's not true. The school children, it's their emissions, and they're actually reducing the emissions of the society as a whole by the work they're going to be doing, and many of the next generation as well as our generation. And then as they do that, then they're bringing about a world along with us as well, in which we're going to have zero emissions. And for instance, take Finland. Then they've got a very ambitious program. They are headed for zero emissions by 2035, 15 years from now. So that means their children, by the time they're 15, then they will have zero emissions. And beyond that, they're negative. So then beyond 2015, Finnish children will have negative emissions as per capita emissions. So it's not true that having more children means that you have more emissions. It doesn't mean that having children means that you're going to be impacting biodiversity as well. because this can all be done in a way that is helpful and useful for biodiversity, in which nature works along with people. And we have natures in our cities, and we use nature services, and we recycle things as well. And it's what they call a circular economy. And right, so that's 1 hour and a quarter. I see I've got to, so maybe I should stop at this point. I think I've said the main points. If you've got any questions, yes, and the people who sign it, well, I explained about that, and how I didn't see any of the climate science co-chairs or any of the others from the IPCC Bureau portal, and I hope you can now understand why top climate scientists haven't signed this paper.